Good morning, technology teachers. I am again very excited to present to you a lesson that's been populated or created by Perplexity AI. So the question or the lesson is all about populated technology grade 9 lesson on Pascal's principle. Equal values of liquids are moved through the systems for grade 9 CAPS curriculum with YouTube video resources according the 5E lesson. And so I'm now currently on the Perplexity platform, as you can see over there. And in the section where I pop the question, I'll just rephrase the question: populate the technology grade 9 lesson on Pascal's principle. Equal values of liquids are moved through the systems for grade 9 CAPS curriculum with video resources according the 5E lesson. And instantaneously, at the blink of an eye, Perplexity AI supplied me with resources, YouTube video resources, and a layout of an answer. Here is a 5E lesson plan on Pascal's principle, specifically focusing on equal values of liquid being moved through systems. The lesson plan follows the engage, explore, explain, elaborate, and evaluate framework and includes relevant YouTube video resources. So it starts off with engage, the lesson. Begin the lesson by asking students to think about how a hydraulic lift works. Show them a picture or a short video clip of a hydraulic lift in action to spark the curiosity, and them they're referring to the learners. Ask students to share their ideas and observations about the hydraulic lift. Encourage them to think about the role of liquids and pressure on the lift's operation. Now we move to the explore stage of the lesson. Divide the students into small groups and provide each group with 2 syringes, a plastic tube, and a container of water. After the students have explored the syringes, gather them back together for a class discussion. Introduce Pascal's principle, explaining that it states that when pressure is applied to a fluid in a confined space, the pressure is transmitted equally in all directions. Show the students a YouTube video that explains Pascal's principle, such as Pascal's principle and pressure by the science classroom. That's the name of the video. And we get to the stage of elaborate. Divide the students into new groups and provide each group with 2 identical containers filled with water, 2 identical plastic tubes, and 2 identical syringes. Instructed the students to connect the containers and syringes with the tubes, creating a simple hydraulic system. Ask the students to explore how the system works by pushing and pulling the syringes. Encourage them to observe the relationship between the volumes of liquid moved into each syringe. And evaluate to assess students and to the understanding of Pascal's principle and its application to equal values of liquid being moved through the systems. Ask them also to write a short paragraph explaining the principle and how it relates to the activities they completed during the lesson. Alternatively, you can use an online quiz or worksheet to evaluate the students' understanding. And so there, Perplexity supplies us with a broad scope of YouTube resources, as you can see over there. And how to solve Pascal's principle? Again, Perplexity AI supplies us with resources. And then to solve Pascal's principle, follow these steps. Identify the enclosed fluid and the pressure applied to it. Determine the area of the surface on which the pressure is applied. Use Pascal's principle to find the pressure throughout the fluid. And then hydraulic lift, Pascal's law, it clarifies Pascal's law with additional resources. Pascal's law is the fundamental principle behind hydraulic lifts. It states that when pressure is applied to a confined fluid, the pressure is transmitted equally throughout the fluid and to the enclosed walls. The principle allows forces to be multiplied in hydraulic system, making them useful in a variety of applications, including automotive brakes, landing gear, and lift systems. Here are some key points about the hydraulic lifts. Hydraulic lift is a system that uses a confined fluid to lift heavy loads. The system consists of two pistons of different sizes connected by a tube filled with fluids such as oil or water. When a force is applied to the smaller piston, it creates pressure in the fluid, which is transmitted equally to a larger piston. The larger piston then exerts a greater force, allowing heavy loads to be lifted with less effort. This multiplication of force is based on Pascal's law, which states pressure applied to a confined fluid is transmitted equally through the fluid to the enclosed walls. And then here's a little embedded video.
Hello everyone, in this lesson we're going to cover the Pascal's principle. So let's understand its statement and explore the most amazing application it has in real life. Stay tuned until the end because we're going to solve a practical example step by step. According to Pascal's principle, a change in pressure applied to enclosed fluid is transmitted undiminished to all portions of the fluid and to the walls of its container. Pascal's principle is named after Blaise Pascal. He was a French mathematician, physicist, inventor, philosopher, writer, and Catholic theologian. But this principle is because of his works in physics. Basically, he's saying here that the pressure at a point in a fluid at rest is the same in all directions. We can make an experiment here. We can take this bulb and make some holes in different parts of this bulb that's full of water, okay, and apply some pressure on it. You'll notice that the water will leave this bulb here with the same pressure in all the holes. That's the Pascal's principle. Another thing that we can deduce from this principle is that the total pressure in a fluid is the sum of the pressures from different sources. So if we have a ball here and apply a force over an area, therefore a pressure on this side and another one on the other side, well, the total pressure inside here will be the sum of the pressures from the different sources, okay? And that's basically the Pascal's principle. Now let's go through some of the applications, okay? Mostly we apply Pascal's principle to hydraulic systems. Well, we have here a small hydraulic system. So we have two cylinders, okay, two pistons that are connected. This piston here has a small area, okay, A1, and we are applying a force here over this small area. Well, you can think that, well, if you apply force here, then this piston will go up. So this another piston with a larger area will go up due to the force that we apply here. Well, let's remember then that pressure is force over area, right? And we have for each side here, we have the corresponding pressure. So according to the Pascal's principle, the pressure of the fluid here, so you're applying some pressure here, and this pressure is transmitted through the entire fluid, and it's going to end here with the same pressure, okay? So the relation we have is that the pressure on 1 is the same as the pressure at 2. So if we consider that this pressure is F over A, we have this relation here. This is pretty useful, pretty interesting, okay? Because what matters here is not the amount of force or the area, okay? But this ratio here of force over area. So for a small area like this, we can apply a small force, and we can multiply this force on the other side by increasing the area. So in order for these two sides of the equation to be the same, if we have a small area and a small force, and on this side here we have a large area, the force needs to be also a large to keep the same ratio on both sides. Okay, this is the principle that we use in most of the hydraulic systems. Your car jack, for example, you have a small cylinder here where we apply a certain pressure, okay, with our hands, with our arms, and it multiplies the pressure to this bigger cylinder, so it has a bigger area, so the force over here will be greater. And that's also the same principle of the hydraulic steering system, okay, in some cars. Nowadays we have the electric steering wheel, right? But back in the day we had hydraulic steering systems.
And
So
thank you. And
notice
those
that
are
we
the
have small
applications of
tubes here,
Pascal's
okay? So
principle
small
in
areas.
real life context. So what I've done here is I've copied a link, and so you can use this link to click on this link, and it will pop you straight to the Perplexity AI site where you can access this particular lesson. Thank you so very much. It was a pleasure and an honor to present this lesson by using Perplexity AI to you. Thank you.